Good morning, everyone. My name is Ivan Pravalov. I'm with LucidWorks. I'm a research engineer working on LucidWorks big data development team. And today I will be talking about large-scale search discovery and analytics in action. So when I think of big data, I think of a following metaphor. Why is it when I ask my teenager to go take the garbage out and I say, by the way, grab the recyclables, it gets done, at least 80% of the time. But if I said, please take the garbage out and after that clean your room, it becomes a big data problem. Clean your room all of a sudden becomes this, forgotten dark data. The point of this metaphor is to communicate one of the characteristics of the big data, especially when it comes to size. It's probably organization specific when the data becomes big data. But that's, for some organizations, it could be going from 100,000 records to 200,000 records. Could start representing some of the pain points of the big data. One thing we probably could agree on is that one of the characteristics of the big data that it is distributed. And so in this slide, we will walk through the user interactions with big data. And you can see the first thing is putting the data on some kind of distributed file system is probably one of the very first steps we would do. And at that point, the user interaction with the big data is probably through either a system administrator or some kind of specialized engineer who could actually interact with the system. What you see here on the left, the data itself is unstructured data. And the reason we're talking about unstructured or semi-structured data today is because according to the research, about 80% of all corporate data nowadays is unstructured. And that's why it's very important to address that type of data. So to improve the interactions with the data, we could be using some tools like NoSQL solutions and like key value store, for example. And then we have some query language, right? So you may have an engineer who's specializing in a specific solution to now interact with the system. But again, the focus here, how do we, as users, interact with that big data and the system containing that? And then this index box on the bottom represents really like a search engine index or data that has been indexed by the search engine. And now you can do some keyword search. And though your interaction becomes a little bit easier, you probably have end user that can actually issue the queries, even though there may be still specific query language involved here. But the key differentiator here is that now you're introducing relevancy into your results set. So now I'm trying to get my more relevant results because that's what search engines do, right? So the question becomes, is even search enough to have a good user experience in how they interact with the data and what they're finding in the information they're looking for? Because keyword search is actually becoming a commodity, right? So the search engines address keyword search fairly well. There are known models that are used for information retrieval, and even out-of-the-box tuned system does pretty well with keyword search itself. But it is the holistic view of the data and the user interaction with that data that is probably becoming more important. And search, discovery, and analytics are the key to unlocking this view of the users and data. It is our understanding how a user interacts with that data, how we can help the user to interact with that data better and find information they're looking for. So from the user perspective, it's, of course, the real-time access to the data is critical. In other words, if I put some record into the system, I do expect to find it immediately or almost immediately. It's aggressive prioritization by the search engine that gives me the more important and more relevant content. For me, the importance could be, recency of the content if I search for the periodicals. But if I'm searching for some historical event, the recency may not be as important. And so this relevancy and importance balance has to be part of that. And it's also feedback and learning from my behavior and providing me data that I'm looking for based on the history of my interacting with the system. On the business side, of course, it's providing business with deeper insight into the users and their behavior, as well as leveraging existing internal knowledge. And of course, cost effectiveness. So with that, what I'm about to cover today is a little bit more of a background about search, discovery, and analytics, about some of the pain points in the industry related to that, and then I'll talk about the architecture of building a platform for search, discovery, and analytics. And then we'll talk about a little bit more specific components for a system like that. And then we'll talk about specifically LucidWorks big data and what lies ahead for our product. So in practice, search, for the search, performance is probably one of the key aspects or characteristics, right? It has to be fast. It has to be real time, as I mentioned before. And the relevancy and importance are some of the key things. Now, presenting results by the search engine is one of the also key components. How do we group results? How do we do aggregation? How do we, there's possible federation of different media types. Maybe disambiguation of the results. So all of that is probably a critical part of the search system user interaction. At LucidWorks, we also believe that experiment management is very critical for any search system. So for example, you're getting out of box, you may be getting a search engine that is fairly well tuned, but it's tuned on some user base and queries that is not applicable to your organization necessarily. So you have to have ability and tools to do your own experiments, based on a small sample of your users, and then tune the system further to make the relevancy better. Some of the discovery components, and these represent some of the things that we're hearing from our customers on a daily basis. Some of the pain points here that some of these components are trying to address is, for example, how do I group my content? And I have vast amounts of content. So clustering will help you with that. I may have, by some way of flaw in the business process or some bug in some feeding system, I may have some near duplicate documents. And if it's internally, it could be more of an annoyance issue when I do a search on a certain keyword and then I get 10 documents that are almost the same. It could be an embarrassing issue if you are exposing that information to the outside world. So discovering these near duplicate documents is a very important aspect of discovery. Uncovering trends, recognizing topics, labeling those topics, those are all the keys to understand the content better. So finally here, more like this, is one of the features that will, on one hand, could improve the relevancy, on the other hand, could improve user system interaction. So as any good big data presentation, we have a cloud here with word cloud. But this slide talks about the analytics, right? So analytics range from very simple ones like term frequencies, how many of this specific term I have in this document, to facets like counts of categories, or how many documents in each category, to click analysis, which is more complex because it kind of captures the user system actions and how we can help user to improve their experience. And then relevancy metrics like mean reciprocal ranking, for example, that kind of tells you when was the first relevant document hit. And that tells us, we can now start comparing product to product and say, okay, well, why is this product only getting, most relevant document on page 2 of the search results? And then finally, some of the kind of like defect-oriented metrics like zero results queries. Maybe I have a flaw in my content. Maybe I'm not indexing the content I'm expecting to index. Maybe my metadata is not right, but why is the user not getting any results? And that's what the zero results queries metric is about. And then helping discover the hotspots in our content. Maybe only 1% of my content is being used 80% of the time. So there could be some operations type adjustments that could be made to make things work more efficiently. And then statistically interesting phrases is another metric that tells us about the collocations and like what are the phrases that we see in the corpus that are not there by chance, but they are statistically interesting. That will tell us something about the content. So these are some of the use cases that we hear from our beta customers, our potential and current customers as well. From different industries, we hear things, for example, from video streaming. Some classification and recommendations are some of the use cases where big data tools like this could be applied. In telecommunications, it's fraud detection, and I'll talk about that a couple of slides later. In social media trend monitoring, and then, of course, logs monitoring for IT. And then in the healthcare, one of the important ones is identifying patients for clinical studies. And speaking of the health care industry, one of our beta customers is intending to use big data platform for personalized medicine. So what they do is they do genome studies and they try to discover genetic variations, and based on certain markers, they could then figure out whether certain markers will be influencing certain diseases or having patients certain diseases, and then based on that they could recommend standard therapies versus alternative therapies. Or in another case, in telecommunications, there's an issue with like people tapping illegally into somebody's line, actually physically tapping into somebody's cable and then using their service for free. And so discovering those, as well as monitoring the service logs for quality of service, for the cost of service, and the time spent on support calls. Those are all the critical ones for one of our telecommunications customer. So if one wants to build a search discovery and analytics platform, what would you need? So first of all, it's fast, efficient, scalable search that supports bulk and near-time indexing. Secondly, of course, the scalability of it is to handle billions of records within sub-second search and faceting. And then on the processing side, there's, of course, processing and computational capabilities. You have to have large-scale, cost-effective storage. And then, as I mentioned before, these experimentation tools that allow you to do sampling of your data are a critical part of that. And to do more advanced analysis and discovery and analytics, you probably want to add some of the machine learning and NLP tools that are out there. So a platform for search discovery and analytics could look like this, where you have these inputs on the left. It could be real-time or batch or bulk. And then you have this processing and storage in the middle, where you have this part of the system that kind of contains your infrastructure or operating system of the big data. Then on top of that, search, discovery, and analytics that allows you to do more advanced analysis and processing of the data. And then, of course, the management of the data and adding collections, adding documents, users, managing all of that on the right-hand side. And then provisioning, monitoring, and configuration is important for the operations. And the last but not least is the API. You do need some uniform way to communicate with your system, to interact with it. Instead of learning dozens of underlying systems, you're learning one API, and that helps. So with that, I would like to talk about specifically LucidWorks Big Data. This is how big data right now is architectured. On the left-hand side, we list the inputs. And so the inputs vary from distributed file system, from actually Hadoop, data stored on Hadoop, to crawling data, to Amazon Web Services, to Twitter streaming connectors. And when the data comes in, it gets stored here in this processing and storage in this middle box. And on the left-hand side of that box, you see LucidWorks Search. That's our search engine, which is built on top of Lucene Solr. And I will talk about that in a later slide. And then the next one is, of course, Hadoop, and then Hive for some of the data warehouse capabilities, and HBase. And then these cylinders basically represent the data we store in intermediate steps of data processing as well as log processing. We provide some APIs like analytics and document service APIs to access the data that has been processed by more advanced tools like OpenNLP, UEMA, Mahout, and these provide some more advanced capabilities for discovery and analytics especially. And again, I will be covering these components in more details. And then one of the important aspects, of course, is how do we manage our users and data, and that's here on the right-hand side. And for the provisioning, monitoring, and configuration, so we use Zookeeper to do, it's a configuration tool. We use it for registry, so all services are Zookeeper aware, and that allows us to do cloud capabilities. For provisioning, we use this tool called Chef, and that allows us to provision on premise as well as on Amazon Web Services. And for monitoring, we use Zabbix. So finally, big data has an API layer that provides this uniform access to all of the underlying services. And we also provide proxies into LucidWorks Search as well as Web HDFS. So what I would like to cover next is the LucidWorks Search component. That's probably that's the key to the search. And as you can see here on the bottom, it is built on top of Lucene and Solr. One of the key things here is that we are certifying Lucene Solr 4.0, which is still in development, hasn't been released. It will be released soon, but it is already certified for our commercial offering, LucidWorks Search. And Lucene Solr 4.0 has done a lot of improvements comparing to the previous version as far as like memory improvements. It is cloud ready. It has near real-time indexing capabilities and transaction logs for recovery. Those are some of the new features of Lucene Solr. But in addition to that, the commercial offering of the search engine that we have, we also add in connector framework that would allow you to actually index different types of data, like for example, Microsoft product or a Documentum product or connectors that could actually understand and out of a box be crawling the data from a specific data source. And it's also a framework, so we make it pluggable, so you can actually develop your own connectors for your own data type or data type that is not currently supported. Security is another improvement in the commercial search engine that we have. So it's out of a box LDAP connectivity. And then user click framework is one of these features that allows us to improve relevancy, but also make it very customizable. So it collects the clicks from the user and basically provides some boosting for specific queries for specific documents. Then business process integration is another nice feature of LucidWorks Search, and that's primarily targeting the indexing as well as the search time business rules support. So you can actually create a business rule that will either mask some data from an end user or add some additional functionality. And finally, advanced administration is another feature. So on the Hadoop side of things, there's of course Hadoop, which provides this distributed computing and processing capabilities for ETL and analytics jobs. And then the whole Hadoop ecosystem, all the open source product that come with or can be used with Hadoop, like HBase, for example. So for HBase, we use it as a key value store, allowing fast data access, and we store things like all our metrics, but it provides us also with the time series capabilities for retrieving those metrics. We're also going to be storing user history in HBase. And currently, we're storing some document attributes, but we'll eventually use it for master record for documents themselves. And Apache Uzi is a workflow orchestration engine that we chose to use. That kind of gives us a lot of different capabilities of workflow orchestration engine, including scheduling. And we found that fairly useful. And as you can tell, we had to do some modifications for our platform. On the machine learning and NLP side, we're using Apache Mahout, and that allows us to do distributed machine learning. And that's the key advantage of Mahout, is that it does run on Hadoop, so it does run in distributed mode. Some of the features that we already implemented include k-means clustering. So when we talk about organizing your content, grouping it, that's what it would be useful for. Statistically interesting phrases or co-locations. Similar documents that allow us to discover near duplicate documents. And classification. So those are the features that are implemented on big data already. Apache UEMA, and I'd say in conjunction with Behemoth, allow us to have this flexible text processing framework that abstracts the annotations that are specific to UEMA. So Behemoth, what it does, for one, it makes it easier to put data on Hadoop. For two, it also abstracts your annotations. So for example, if today a customer wants to use UEMA, they can do that. But if they want to use like Gate, another text processing framework, they could also easily switch because Behemoth will support both. So when it comes to features like named entity extraction, like here we're using OpenNLP. For one, it plugs into UEMA, but for two, when I say give me a person annotation, I don't ask for specifically UEMA person annotation. I'm asking for a generic one. So that kind of creates this abstraction layer. It makes the whole architecture more pluggable for the future. Finally, Apache Pig is helping us to write the analytics MapReduce jobs and programs, and saves. It's on one hand, it's a productivity tool, and saves a lot of time. We use it for ETL and log analysis processing. So on the middleware, as I mentioned before, we use Apache Zookeeper for service discovery. Alongside, we use Netflix Curator that talks to Zookeeper. It kind of is another abstraction layer from Zookeeper, so it's a Zookeeper client. And Apache Kafka for all kind of asynchronous messaging that we have. So primarily, this is used for consume the logs from production, as well as for our event-based real-time document processing framework that we use. So what integrates this together is the SDA engine itself. It provides the RESTful services. We're using Servlet 2.1. It also is Zookeeper aware, and all the services are registered with Zookeeper, so that makes it cloud ready. It provides authentication and authorization, and exposes the proxies for LucidWorks Search, Web HDFS, and in fact the Uzi workflow engine. So what lies ahead is our focus will be on three directions here. Analytics, it's further improvement and adding more metrics on relevancy, how a user interacts with the system, on data quality and discovery. One of the next steps we're planning on doing is integrating with one of the existing packages like R, so that if you have in-house data scientist or data analyst that is used to maybe using R package, we'll be providing some outputs so that data can be analyzed further. On the machine learning side, we'll be, of course, adding more NLP features, and one of them would be topic labeling, as well as recommendations. And of course, experiment management, as I mentioned, is one of the critical components, and that's on our roadmap. So in conclusion, search discovery and analytics, when combined into a single integrated system, provides powerful insight into both your content and your users. And we've combined many of these things into LucidWorks Big Data, which provides you a unified development platform for big data applications. We've also integrated a lot of open source projects into it. And it provides single uniform REST API. It is also pre-tuned by open source industry experts. As I mentioned before, we provide out-of-the-box provisioning for hosted or on-premise. So with that, I would like to turn to questions.
Want to raise your hand if you have a question? I can hand you the microphone.
So who would be your typical customer?
So the typical customer would be, so some of the customers that we're talking to right now are ranging from healthcare industry, a large organization that has big data that would like to learn and basically discover something new about their content and how the user interacts with that content, that would like to turn their system around and make it user-centric. But also for organizations that are actually switching and would like to get like one integrated platform for a lot of, for things that are pain points currently.